You ever stop and wonder how a massive system, like Amazon or your bank, manages to keep millions and millions of records straight without just collapsing into a total mess? Well, it's definitely not magic. It's all thanks to a set of really powerful, kind of hidden rules. And in this explainer, we're going to pull back the curtain on one of the most important ones of all, the functional dependency.
All right, so let's get right into it by looking at a problem I'm pretty sure we've all run into at some point. You know what I'm talking about. Messy, repetitive, totally inconsistent data that just turns even the simplest tasks into a complete nightmare.
Just take a look at this student table here. See that? The department name CO is always paired with building A4. Now imagine you have 1,000 computer science students. That means you're typing A4 1,000 times. I mean, not only is that super inefficient, but think about this. What happens if the department moves to a new building? You'd have to hunt down and update every single one of those entries. And you better hope you don't miss one, because then, chaos. And look, this isn't just some minor annoyance. This is a critical design flaw. It basically opens the door for all kinds of errors and just makes the data totally unreliable. But the good news is there's a really formal, kind of elegant solution that's designed to stop this chaos before it even starts.
And that solution is exactly what we're here to talk about. It's called a functional dependency. And honestly, it's probably the single most important concept you need to know for designing clean, reliable databases. Seriously.
So what exactly is it? Well, at its core, a functional dependency is really just a rule. It's a constraint, a law that says if you know the value of one thing, then you must know the value of another. It creates this super strict, predictable relationship that just brings order to the data. And hey, like any good rule, it's got its own simple notation. And once you see how it works, it makes everything super easy to understand. You're going to see it written like this: A, an arrow, pointing to B. We read this out loud as A determines B. You could also say B is functionally dependent on A, but what it really means is simple. For any single value of A you pick, there will be exactly one corresponding value of B. Not 2, not 0, 1. So let's break down these rules a bit more. A, the one on the left, that's the determinant. Think of it as the key. It's the piece of information that's in charge, the one doing the determining. And B, on the right, that's the dependent. Its value is what gets determined by A. It's the information you get once you have the key. And this rule is absolutely critical. Think about it this way. An employee's unique ID number must determine their one single email address. If you look up employee 1138, you have to find one email, and only one. You can't find two, and you can't find none. That certainty, that predictability, that is the whole point. That's a functional dependency in action, right there. Okay, so let's bring this rule back to our student table. Using this formal A determines B notation, we can now really precisely describe the relationships that were kind of hidden in that data before. All right, here's where the rubber meets the road. Does role no determine a name? Yes, absolutely. You give me a roll number, you get one name back. That's a valid dependency. How about dept name determines dept building? Yep, that works too. CO always points to A4. But what about the other way? Can a name determine a dept name? No way. Look, the name XYZ shows up with both CO and IT. That breaks our rule. For one value of A, we're getting multiple values of B. That's a big no-no. This whole concept is so foundational, so important, that a bunch of brilliant mathematicians and computer scientists actually developed a set of logical rules to go with it. They're called Armstrong's axioms, and they basically describe how all these dependencies behave and interact with each other. We're not going to go through all of them, but let's look at the most intuitive one. It's called transitivity. And honestly, it works exactly like a chain of logic. If A leads to B and B leads to C, then A must lead to C. So if we know a student's roll-on note determines their dept name, and we know that dept name determines the dept building, well, then it just makes sense, right? It logically follows that the roll-no-no must also determine the dept building. It's like a logical shortcut. So this is the part where you might be asking, okay, why are we doing all this? Why get so formal about these rules? And the answer is pretty simple. The payoff is massive when it comes to building better, more reliable systems. Because by actually finding and enforcing these dependencies, we get some incredible benefits. We guarantee our data is consistent. We dramatically improve its quality. But maybe most importantly, We have a formal tool that helps us spot bad designs before they become huge problems. This whole idea, it's the very foundation of something called data normalization, which is just the fancy term for organizing data to get rid of exactly these kinds of messes. And here is what that looks like in practice. It's the big reveal. We take our one messy table from the beginning, and using the functional dependencies we found as our guide, we split it. We break it into two smaller, much cleaner tables. Now we have one for the students and one for the departments. So the fact that the CO department is in building A4, well, now that fact is stored in exactly one place. No more repetition. And really, this brings us to the ultimate goal. The one simple but incredibly powerful principle behind all of this is store each unique fact in exactly one place. That's it. And functional dependencies, they're the tool we use to enforce that rule of one. So, in the end, functional dependencies are like the invisible grammar of data. They're the hidden rules that bring structure and reliability to the information that powers our entire world. They're the reason that when you look up your order number, you get your order and not someone else's. And that kind of leaves us with a final question to think about. What other invisible rules are out there, silently making our digital world just work?